Okay, here's the next example, part C. This is a series n times x plus 1 to the n. And if you apply the ratio test, the ratio as n goes to infinity goes to n plus 1 times x. That's a plus 1. And the limit as n goes to infinity of n plus 1 goes to infinity. So there is no limit except at one point where x is equal to negative 1. X plus 1 is 0, so the limit equals 0. So this power series converges only at one point at x is equal to negative 1, and it's an absolute convergence. So we don't have any endpoints test there. It converges only at one point. The next example, part D. This one, you apply the ratio test, and you get the limit of the ratio is right here. And that is, this part goes to 1. So the limit ends up being the absolute value of x minus 3, which has to be less than 1. So the interval of convergence, the absolute convergence, is an open interval between 2 and 4. So the final step is to test at the endpoints, what happens at the endpoints. And this one, at x equals 2, if you plug in x is equal to 2 into the series, you end up with negative 1 raised to the n over 2n, which is an alternating harmonic series, which converges conditionally. And if you test x is equal to 4, the other endpoint, it becomes 1 over 2n to the nth, 1 raised to the nth over 2n, which is a harmonic series times 1/2. Which diverges. So this original power series converges from 2, including 2, to 4, not including 4. So this is the final interval of convergence. Okay, so the next few pages has different examples from the exercise section. Here's number 35. So I want you to take your time in looking at these examples. Maybe do them first and look at my solution. And this is number 4, just another example of how to test the endpoints. And when you're done with those, you can do these 3 problems, 36, 38, and 40 for homework. And I will post the solutions to these problems as a separate attachment. Congratulations, now you're done with chapter 9.